we're going to add to our polynomial factoring techniques some special factoring. And one of my favorite factoring techniques is the perfect difference of perfect squares. I don't know why I especially like this one. It's probably because it surprised me multiple times in my big factor completely problem. So you'd factor, and there, voila, another difference of squares factoring would happen. And we just got to get used to looking for and recognizing what are a difference of squares. So the formula says a squared minus b squared is equal to parentheses a plus b times a minus b. So it is the product of conjugates, which is pretty cool. That's a whole nother realm of work with our math and factoring and rationalizing whole stuff. But anyway, difference of squares, it rewrites to be the product of a binomial pair of conjugates. And to recognize the difference of squares, we need a running list of what some common squares are. So let's just throw these off to the side. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and we'll just stop at 10 squared. And of course, these are elementary works, the diagonal of your multiplication chart when you were in elementary school. And so we've got 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Now, you really want a running list all the way out to probably 15, maybe 25. I have a very nice chart on my wall in my classroom that would help people out, but that doesn't help us here on this screen. So we're going to just leave it as is for now and just see the 121 and realize, hey, that's not even on my list. Well, that's the next one. It's 11. So this is 11 squared. And so you just want to recognize that that is a square and that this x is x squared, the quantity squared, and there's a minus sign in the middle. It's really that simple. It's the difference of squares. These are some numbers squared. 121 is 11 squared, and x is the number x squared. As soon as you can recognize that difference of two squares, we call the first one a. We call the second one b. And then all we do to factor it is just throw it into the formula right here. This is equal to parentheses. The first term is a, so that's x, plus the second term was b, 11, parentheses. First term again is a, is our x, minus the second term, which was the 11. So it's just a matter of recognizing what is the a and what is the b. In other words, what is the first thing that got squared to be the first term, and what's the second thing that got squared to be this second term. Once you recognize it, you just write a plus b times a minus b. So we're going to look at a bunch of different examples as we roll through. So in this second example, I quickly mix it up. I don't make it much more complicated, but I reverse the order. We want to recognize that the first term is not always a variable. This time it's a number, but it is a square number. And by square number, it means something squared gives you this number. The thing that can be squared to give you that number is 2. 2 squared gives you 4. And then this is x, so it's minus, I'm just going to put it in parentheses to make it kind of look similar, x squared gives you that number. So the idea is that this is your a, and this is your b, and so the formula goes, if it's a squared minus b squared, it's always parentheses a plus b times a minus b, and so this just has 2 plus x times 2 minus x. As soon as we recognize the a is 2 and the b is x, we just put it in the corresponding locations and we will have the answer. The reverse order here doesn't matter. If you wanted to put them in standard form descending order for each factor, you could. This is perfectly sufficient. It works, but I will rearrange it. You know that addition can be written forwards and backwards, so we could just write x plus 2. And then this one, to rearrange it, you really have to factor out a negative. And so we could do that since we're really practiced on our GCFs. You could factor out a negative 1 from here. And so if I divided each of these by negative 1, this would be 2 divided by negative 1 is negative 2. And x divided by negative 1 would be a positive x. And this negative 1 is being multiplied between the two parentheses. So you see all of a sudden this problem got complicated when I was already saying, hey, that's the first answer. And that's okay. sometimes we will have to rearrange it though. So here, now that it's a plus sign, we can rearrange this to be x minus 2. This negative sign I would put out in front of everything and just make it a negative 1, but you don't have to write the 1, parentheses x plus 2 times x minus 2. So this is probably the better form of the answer if we were going to go ahead and graph or find the roots and that sort of thing and identify in behavior for this graph. But just factoring, this would have been where I would have stopped for difference of squares. So now we're going to up the rigor a little bit where both terms have coefficient parts, but still we're just looking for what squared gives us these two numbers. The first number is 8 squared, gives me 64. The second number, put a minus sign, and you got to think about both parts. Well, the thing that gives me 9 by squaring is 3, so it's 3, and then x squared. So you put 3x in parentheses and put the square up over top of the whole parentheses, because if you distributed this square to both the 3 and the x, you would come back and you would get the 9x squared. So I'm just direct substituting to recognize that this is my a and the 3x is my b. So it's going to be a squared minus b squared. And the formula says I just do a plus b times a minus b. So this is 8 plus 3x times 8 minus 3x. As soon as you recognize what the a and the b are, you just write two sets of parentheses, one with a plus sign, one with a minus sign in the middle. You don't have to necessarily write the formula each time. I'm just trying to get it to sink in as we work. This is the answer this time. Just like the last problem, if we wanted to rewrite this, and now that we're maybe a little quicker on it, factoring out a negative would be negative, and then the signs change. So it's going to be a negative 8x, or sorry, negative 8, and then a positive 3x if I pulled out a negative. And so I could just rewrite it to be 3x minus 8. And then this parenthesis, you can put it, since there's a negative 1, I'm going to put it in front of both of them. So ultimately, I want the negative to be out in front. Negative 8 plus 3x. I guess I was going to rewrite that one too, right? So 3x plus 8 times 3x minus 8 would be the better form if you were trying to factor. And that's from factoring out this negative if you desire to. But again, this is already factored correctly with the difference of squares. And now for my favorite version of the difference of squares, we've got a 1 in there with an x squared. And why this is my favorite version is because it's one that just either this version or if it was written as x squared minus 1, these two problems are stumpers for a lot of students because we just don't recognize 1 as being a square. Well, 1 is a square. 1 squared is 1. And x squared is x squared. So x is b and 1 is a. And over in this problem, it would just be reverse order. This would be a and the 1 would be b. So it would be x parentheses squared minus 1 parentheses squared. I'll do both of these problems because you'll see both variations throughout your math work. So this one, just getting used to it, you just, once you identify the a and the b, you write a, b, 1 with a plus sign, 1 with a minus sign, and you're done. It's factored. Now that one, again, unlike the last two problems, I'm probably going to want to factor out the negative on there, but we'll leave it like that for now. And then here on the second problem, once you recognize this is a and that's b, it's just write a, b, parentheses, write a, b again. One of them gets a plus sign treatment, one gets a minus sign treatment, and there it is factored. So 2 problems in one on one slide here, and we'll get those working for us. And again, if I wanted to factor out a negative, this one, if I rewrote it, it would be negative, and then I'll write this to be x plus 1 in reverse order, and then this one will be x minus 1. So this is an equivalent form of this purple box up top. And that's the intro to difference of squares factoring. We're going to get much more complicated ones with more and more variables, recognizing squares of higher degree than just 2. Any even degree is actually a square, which is what we're going to look at in our next little section.